Okay, here's a statement that might ruffle a few feathers, especially if you're deep in AI development right now. You might actually need to stop building AI agents.
I know, right? That sounds almost heretical, doesn't it? Especially with, well, all the excitement around frameworks like Crew AI and AutoGPT. It really feels like agents are the solution everyone's reaching for, the cutting edge.
They definitely have that allure,
Yeah.
that excitement. But let's be honest, that initial buzz, it often turns into frustration, doesn't it?
Mhm.
What if we told you that for a lot of your projects, agents are maybe the most overhyped pattern in AI today?
Hmm.
That they are often, the wrong first step,
Better.
leading to more headaches than actual breakthroughs.
And that's exactly our mission in this deep dive. We're going to unpack why jumping straight into agents often leads you right into, well, debugging nightmares and systems that just aren't that robust. We want to show you the specific kind of limited situations where agents really do make sense, and maybe more importantly, introduce you to 5 simpler, often much more effective workflow patterns. Patterns that will save you, honestly, a lot of time, effort, and stress.
Think of this as your shortcut, you know,
Yeah.
a way to avoid those common pitfalls and build AI systems that actually work reliably. So whether you're prepping for a meeting, just trying to catch up on the field, or you're deeply curious about building better AI, you're in the right place.
Definitely. We've spent months working with, dozens of teams building LLM-powered systems, and we see this pattern again and again. Developers immediately jump to agents.
Right.
They set up these really complex memory systems, intricate routing logic, super detailed tool definitions, and it feels like progress. It feels
Yeah,
powerful.
it absolutely does. Almost magical, you could say, until inevitably something breaks.
Exactly. And when it does, the sheer complexity of these agentic systems makes finding the problem almost impossible. The LLM outputs aren't always predictable, right? So reproducibility becomes a nightmare. That right there, that's the core problem we want to tackle today.
Okay, let me illustrate this with a story. It'll probably sound familiar to some of you. About 6 months back, I built what I genuinely thought was like the perfect system. A research crew, all crew AI powered, 3 agents, 5 tools, looked great on paper. The dream setup.
That sounds like the exact vision, right?
Yeah.
The thing everyone imagines when they first explore agents, this potential for truly autonomous, self-directing workflows.
Totally. I had a researcher agent, a summarizer, a coordinator. It was elegant, it looked beautiful, and it was completely, utterly broken.
Oh, no.
Yeah, the researcher just ignored the web scraper it was supposed to use. The summarizer kept forgetting the citation tool, even though it had one.
Yeah.
Find right there.
Classic.
And the coordinator, it basically just gave up when processing longer documents.
Right.
Threw its digital hands in the air. It was a beautiful plan, but man, it fell apart in spectacular, really frustrating ways.
And what's fascinating and kind of worrying is how often developers fall into this exact trap. When people say agents, they usually mean that final, super dynamic step where the LLM's output controls everything, decides its own path.
Right, the fully autonomous thing.
But what you found and what we see constantly is people skip straight to that. They let the LLM control the whole workflow without realizing that often much simpler patterns work better, they're more predictable, and they save you countless hours of debugging hell.
Yeah, exactly. I actually made this debugging flowchart afterwards, trying to figure it out, and the little box at the very end, the tiny one, that was actually use an agent. That's how rarely you really needed it for a robust system, yet everyone starts there. Using an agent means handing control to the LLM. But unless your task is so dynamic, so unpredictable, that you literally cannot define the flow up front, that freedom usually hurts more than it helps. The unpredictability, the lack of deterministic behavior,
Yeah.
those become huge liabilities.
So why does this keep happening? It's a good question. Developers see multiple complex tasks they want to automate, and agents just seem like the obvious, most powerful, maybe the coolest solution.
Definitely the coolest.
So they build these incredibly complex systems, intricate roles, fancy memories, sophisticated tools only for it all to break because coordinating it in the real world is way harder than it looks on the whiteboard.
Been there.
And then they spend weeks debugging, only to realize, often too late, that simpler patterns would have worked better, faster, and been far more reliable from the start. It's a common and, yeah, deeply frustrating cycle.
Does that sound familiar? I bet it does for some of you listening. But here's the good news. You're definitely not alone. And there's these 5 simple workflow patterns that can solve most problems without the complexity, the headache, or the debugging nightmares of full agents.
Yes, these patterns are your escape route from agent hell. Each one is simpler, much easier to debug, and crucially, they actually work reliably in production. You can ship features confidently. Let's walk through them. Think about how you might use them.
Okay, good idea. For illustration, let's imagine your goal is to extract specific data points from LinkedIn profiles, like job history, skills, and then generate personalized outreach emails based on that info.
Yeah, that's a super common real-world use case for LLMs, bridging data processing and content generation. Okay.
Right. So first pattern, chaining. This is basically tasks flowing one after another, like dominoes. You take the raw LinkedIn text, then one process extracts the structured data, then that structured data feeds into the next process to write the email, step by step.
It's really simple. You use it when your tasks have a clear sequential dependency. One thing has to finish before the next starts. The main failure mode is also simple. If one step breaks, the whole chain stops. But that simplicity makes debugging easy. You know exactly where it failed, so you can iterate quickly, build really reliable systems when tasks naturally follow each other. It's like building a predictable assembly line for your data.
Okay, next up, parallelization. Now imagine you need to process lots of LinkedIn profiles, not just one. Instead of doing them one by one, you maybe split each profile into its independent parts, education, work, experience, skills, whatever, and then run the data extraction for each part at the same time, concurrently.
This pattern is fantastic for independent tasks that can run simultaneously. It makes your whole process much faster, much more efficient, especially with large amounts of data. And importantly, it isolates failures.
How so?
Well, if one parallel task messes up on, say, the skills section of one profile, it doesn't necessarily stop the processing of the work experience section or other profiles entirely. Troubleshooting, it's way easier. You just need to watch out for standard concurrency things like race conditions, timeouts, but those are known problems in software development.
Makes sense. Okay, third pattern, routing. Let's switch examples maybe. Imagine you're building a customer support tool. It needs to handle different kinds of incoming queries, product questions, billing issues, refund requests, you name it.
Okay.
Routing logic is what looks at each message, figures out what it's about, and then sends it to the right. Specialized workflow designed just for that type of query.
You use routing when different inputs need fundamentally different handling, different paths through your system. And the real power here isn't just efficiency, it's also about keeping prompts effective.
Ah, right. How?
By sending the query to a specialized, smaller workflow, you keep the LLM prompt for that workflow super focused. Less noise, fewer chances for hallucinations, much better accuracy for each specific task. A key thing here, a best practice, is always have a catch-all route for anything that doesn't fit your category so nothing gets lost.
Good point. Okay, now we're getting closer to something that feels a bit agentic, but with way more control. Orchestrator Worker. This is a really powerful pattern. You have a central orchestrator component that breaks down a big, complex task into smaller, manageable subtasks. It then intelligently delegates those subtasks to specialized worker components, each built for a specific job.
Now, at first glance, this might sound a bit like routing, maybe even a simple agent setup, but here's the key difference, and it's really important. The orchestrator stays in control the whole time.
Okay.
It's not just handing off a task and forgetting it. It's actively managing the flow, coordinating the workers, checking their progress, often pulling the results back together into one final output. Think of it like a conductor leading an orchestra, not just a traffic cop waving cars through.
I like that analogy.
It gives you this controlled form of agentic behavior. The core logic stays predictable, but the LLM can help with dynamically breaking down the task and delegating. It bridges that gap between rigid workflows and total autonomy.
Okay, last one. The evaluator-optimizer pattern. This one's particularly useful when the quality of your output is really critical. More important than just speed or getting something out in one go.
Right.
So you generate some initial content, maybe a draft email, a first pass at summarizing something, then you have an evaluator step that checks its quality against criteria you set. Does it meet the standard?
And if it doesn't?
If it doesn't meet your standards, you loop back. You optimize or refine it. Maybe try a different prompt, tweak some parameters, generate again, evaluate again until it does pass muster.
This creates this really crucial feedback loop, kind of like how a human would review and improve their own work. The trick is setting very clear, measurable stop conditions so you don't loop forever.
Yeah, infinite loops are bad.
Definitely. But when you apply it right, it ensures really high-quality, polished outputs. It's like built-in quality control, mimicking that human review cycle. It's about failing fast to learn and refine, guaranteeing a better success rate for subjective tasks where just good enough isn't, well, good enough.
Okay, so we've got these 5 patterns. Chaining, Parallelization, routing, Orchestrator Worker, and evaluator-optimizer. What does this all mean for you, the listener, building your next AI app?
The big takeaway, I think, is that most use cases really don't need those complex, unpredictable agents.
Exactly. They need better, more robust workflow structures.
So maybe ask yourself, are you guilty of reaching for agents when a simple chain or a router or maybe that orchestrator worker setup would work more reliably and be way easier to maintain?
It's a really common impulse, like we said, because of all the excitement. But if you connect this to the bigger picture, it's fundamentally about using the right tool for the job. And often, honestly, the simpler tool is the better tool.
Okay, so I've been maybe pretty harsh on agents so far, focusing on the pitfalls, but here's my, let's call it a counterintuitive hot take. Agents do excel, but specifically at unstable workflows where you can have human oversight, where a person is there to catch and correct mistakes. This is such a critical distinction. This is where the nuance really comes in. Agents shine brightest when you're looking for creativity, maybe, or broad exploration of possibilities, or handling really unpredictable open-ended inputs, and you have a human actively involved.
Right. Providing direction, validating output, course correcting.
Exactly. They are fantastic assistants, not fully autonomous decision makers.
Okay, give me an example.
All right, think about a data science assistant. This isn't some rigid workflow. It's an agent that could dynamically write SQL queries for you, generate different kinds of charts, maybe even suggest advanced stats analyses, all based on you just asking it in natural language.
Okay, I see. So the human is still driving.
Absolutely. You, the human data scientist, are there to evaluate the results, spot if the interpretation seems off, guide its next steps, explore different ideas. The agent's creativity in exploring data paths in that scenario often beats a predefined workflow because the whole point is discovery and iteration.
That makes sense. What else?
Or how about a creative writing partner? An agent that helps brainstorm headlines for an article you're writing,
Yeah.
or edits your copy for tone, or suggests different ways to structure a story.
Yeah.
In these cases, the human's judgment about aesthetics, about emotional impact, is essential. The agent is great for throwing out ideas, giving you lots of options, maybe some unexpected angles, but the human provides that discerning eye, the final creative direction. It's a real collaboration.
Okay, one more.
Sure. A code refactoring assistant. An agent that could look at your code and propose design patterns to improve it, maybe catch subtle edge cases you missed, or suggest performance optimizations. The human developer reviews, then approves or rejects the changes.
Right, like a superpowered linter or code reviewer.
Exactly. Agents can spot patterns across huge code bases much faster than a human sometimes. They serve as an invaluable second set of eyes.
So what's the common thread in all those examples?
What's consistent and absolutely vital is the human in the loop. The agent is augmenting human intelligence. It's not replacing it, which naturally raises the flip side of the question for you. When should you definitely not use agents?
Yeah, this is just as critical to understand. There are clear warning signs. First, enterprise automation. If you're building stable, reliable software that has to be deterministic, auditable, production systems.
Things, processing orders, managing inventory, core business logic.
Exactly. Do not use agents for that core workflow. You just cannot have an LLM deciding critical business processes where stability, predictability, accountability are absolutely paramount. The cost of an error is just too high.
Precisely. And second, related to that, high-stakes decisions. Think financial transactions, medical diagnoses, legal compliance checking, safety-critical systems.
Anything where mistakes are really bad?
Exactly. These absolutely demand deterministic logic, clear audit trails, highly predictable outcomes. Not LLM guesswork or potential hallucinations or weird, unexplainable deviations. The margin for error is zero or close to it. You can't trust that to a non-deterministic agent. The consequences are just too severe.
So remember my broken crew AI system from earlier?
yeah, the disaster.
Ah, yeah. From those spectacular failures, I learned some really vital lessons that apply to any attempt to build agents, I think. My agents, they assumed context they just didn't have. That's why the summarizer forgot citations and long docs. It lost the thread.
Right, context windows and memory are hard.
They also failed, reliably anyway, to pick the right tools. The researcher ignored the web scraper even when it obviously needed it. And crucially, they just couldn't handle coordination when tasks weren't super clearly, meticulously scoped out and constrained. The behavior that emerged was just chaotic.
So the harsh but necessary lesson here, if you are going down the agent path, is you have to treat them like complex software systems. Full stop. Meaning you cannot skip things like observability, detailed logging, robust error handling, comprehensive testing. They need the same engineering rigor, maybe even more than any other critical software you build. Without that rigor, you're essentially building a black box that will fail, probably in confusing ways.
Okay, let's try and distill this down. Practical takeaways you can use, like tomorrow. First, start simple. Use predictable workflows like chaining or routing. Unless you know, like really know, you absolutely need the dynamic memory, delegation, and planning that agents might offer.
And most cases really don't. A good question to ask yourself right at the start is, can I define this workflow upfront with clear steps, maybe some conditions? If the answer is yes, just skip the agent. Use one of the simpler patterns. It will save you so much grief.
Third point, remember where agents actually excel those human-in-the-loop scenarios? Creative ideation, exploring possibilities, acting as an assistant where you provide the oversight and direction. That's their sweet spot.
Fourth, stay away from agents for stable enterprise systems or high-stakes decisions. The complexity, the unpredictability, the debugging pain, it's just not worth the risk when determinism and reliability are absolute must-haves. The operational burden is way too high.
And finally, number 5, build with observability and explicit control from day one. Doesn't matter if you use agents or simpler patterns. You need to understand what's happening inside your system, what inputs, what outputs, why decisions are being made at every single step.
Think of it like a quick decision tree for your next LLM project. Is the task sequential? Use chaining, independent parallel work, parallelization. Different inputs need different handling. Routing needs specialized workers coordinated by a central manager. Orchestrator worker. Output quality and refinement, critical. Evaluator-optimizer.
And only reach for agents when you have those truly dynamic workflows you absolutely cannot define upfront. And crucially, you have that human in the loop to catch mistakes, provide context, guide the process. This isn't about being anti-agent, right?
Not at all.
It's about being pragmatic, understanding the costs and benefits, using the right tool for the job you're actually trying to do, not just, the trendiest tool.
It's so easy to get caught up in the hype in AI. It moves so fast. You feel like you need the most advanced, most autonomous thing for every single problem. But sometimes the best solution, the most robust, the most reliable one, is actually the simple one, built on predictable patterns.
Agents absolutely have their place, but that place is often much smaller, much more niche than people generally perceive. Start simple first. Introduce complexity only when it's truly necessary for those dynamic, unpredictable workflows that you just can't map out beforehand, and where human oversight is a given.
And maybe a final thought to leave you with, as you think about this, always remember that even in those dynamic scenarios where agents might seem perfect, the most critical component, it's often that human in the loop. Providing essential oversight, correcting mistakes, it really underscores that vital balance between what AI can do, which is impressive, and the indispensable role of human intelligence in ensuring accuracy, control, and ultimately success.